Thank you very much. First of all, I want to express my gratitude to Professor Hamama and to all the friends on Marrakesh Fertility Institute for inviting us to be here today. It's our first time in Marrakesh, even first time in Morocco, despite that we are so close. So it's been a pleasure. And I would like to also thank for giving the opportunity to revisit the topic of progesterone, the impact of progesterone during the follicular phase, because, well, it's now 35 years since this first paper was published, in which for the first time a potential relationship between progesterone levels at the end of stimulation and IVF outcome was described. Since then, probably there has been hundreds of papers that have been already published, some of them showing that there is an association, some of them showing that it's not. But there is evidence enough to undergo for a deeper analysis, and this is what I invite you to do with me now, because it's not about analyzing associations. We need to analyze if there is a cause-effect relationship between the increase of progesterone and cycle outcome. And for that, the best tool that we have is not new. This was described 60 years ago and are the Bradford-Hill criteria to analyze if there is a cause-effect relationship between two events. And this is what I invite you to undergo on the coming minutes. Here, just to summarize which are the 9 Bradford-Hill criteria. As we can see on the screen, we have temporality, we have plausibility, consistency, strength, dose response gradient, reversibility, study design, evidence, and analogy. And we are going to review all of them. Through the lens of Bradford-Hill criteria, we're going to analyze the relationship between progesterone levels and cycle outcome. So the first criteria is very clear. Temporality means that the cause obviously needs to precede the effect. And it's quite obvious that we are speaking about progesterone elevation the day that we're triggering, and what's the impact that it has with embryo implantation. And obviously, the potential cause is preceding the effect, because this is happening around 8 to 10 days before embryo implantation is happening. So without any doubt, we can say that yes, the temporality criteria is fulfilled by this relationship. What about plausibility? Is the association consistent with the existing knowledge? And the answer is yes. We know for many years that there is a clear relationship between progesterone and its effects on the endometrium. Physiology shows us very clear that the action of progesterone in both the epithelial but also on the stromal cells of the endometrium is clue to transform the endometrium from the proliferative stage to the secretory stage and to make it receptive. So definitely there is a clear plausibility of these two events. Have similar results been shown in other studies? Obviously, it's not the same if a potential relationship has been observed in just a few studies than if it has been confirmed in so many studies. And definitely on this topic, we have one of the probably largest meta-analyses in our field, which included 63 studies, included more than 55,000 IVF cycles. And this meta-analysis by Chris Benettis more than 10 years ago showed that definitely there was a clear association between high progesterone levels at different thresholds at the end of stimulation and the probability of achieving an ongoing pregnancy or even a live birth. What about the strength? What is the strength of the association between the cause and effect? Because you can find an association, but if this association is not strong, the probability that there is a cause-effect relationship is much weaker. But if we go to the data and we observe what's the impact of high progesterone, we see that patients that have an elevated progesterone, described as levels above 1.5 nanograms per ml the day of trigger, have a very strong impact. The difference in ongoing pregnancy rate shows an odds ratio of 0.53, which is really a remarkable clinically relevant difference. Therefore, the association is strong. We were observed to see at that time that this was happening either in the antagonist protocol or in the long agonist protocol. The odds ratios, as you can see, were virtually the same. So there is a strong relationship between the cause and the effect. What about the dose response? as we increase the exposure, are we increasing the effect? This is a very good question, and we can look at this from 2 points of view. On one hand, if this is true, the higher the progesterone, the lower the pregnancy rates. And this is proven. This is the study that we published 15 years ago, including more than 4,000 patients. And you can see that there was an initial drop on cycle outcome when progesterone was about 1.5. When you look to patients which progesterone the day of trigger was above 2, the impact on ongoing pregnancy rate was even higher, with very low chances of success, just 11%. So increase of the exposure increases the effect. But not only about how high was progesterone the day of trigger, also about for how long it was increased. This is another way of looking to an increase of the exposure. And we know also that the longer the exposure to high progesterone, the higher the impact on pregnancy rates. As you can see on this study by Huang, when progesterone was increased for 3 days or more, the impact on pregnancy rates was higher than if progesterone was increased for just 1 or 2 days, and definitely higher if it was not increased. So these two observations prove that there is a dose increase, a dose relationship, dose-response relationship between the exposure and the effect. Does the removal of the cause, reversibility, does the removal of the cause decrease the risk of the effect? Another interesting issue. But when we look at the outcome on frozen embryo transfers, we see that, yes, when we are removing the cause, we are removing the effect. When we are transferring frozen embryos, we are not exposed anymore. The endometrium is not exposed anymore to this high progesterone, and the effect is disappearing. This was proven, again, comparing the outcome between frozen or fresh embryo transfers. This has been proven later on PGT analysis, in which, of course, we're freezing the embryos. It's been shown that high progesterone does not impair the outcome on PGT cycles. And also for us was also very important to analyze this on the oocyte donation program to make sure that if progesterone was increasing in the donors, we were not affecting the outcome on the recipients. And this is exactly what we observed in the study by Marco Mello published in 2006. We observed that this was the same donor undergoing 2 ovarian stimulation cycles. So they were not a different population of donors. It was the same population of donors. In one cycle, they had low progesterone. In the other cycle, they had high progesterone. And these didn't have any impact on the outcome of the recipients. So when we are removing the cause, we are avoiding the effect. Is the evidence based on a robust study design? Again, it's not the same if we are observing an association in a weak case control study than if we are looking for stronger evidence. And definitely we know that the top of the pyramid of scientific evidence are meta-analysis. And I already alluded to the meta-analysis by Chris Benetis that showed this effect. But even if we look to individual studies, obviously we cannot do randomized controlled trials. We cannot intervene in increasing the progesterone or not. Therefore, we need to go to core studies. But core studies showed that, again, our study with more than 4,000 cycles, and there has been other very large studies showing that there is the effect there. So the quality of the studies that is showing this association is strong, is high. We're speaking about large core studies and speaking about meta-analysis. One other way to analyzing the potential relationship between two events, the potential cause-effect relationship, it is what is called triangulation. This is very important because a triangulation is a tool to avoid flawed data. I mean, if we repeat the same type of study many times and there is some kind of wrong assumption behind the design of that type of study, no matter how many times we do the study, we will always fall in the same mistake. So that's why it's very important that when we want to analyze these cause-effect relationships, we have different points of view. We are looking to the effect from different angles. This way, with different methodologies, this way we will decrease dramatically the probability that we are having artifacts. And here I show you some examples of looking at this on from a different scope. First, a study by Dimitra Kiru from Brussels. She didn't look at the levels of progesterone just the day of trigger. She looked to the exposure of progesterone across the whole follicular phase, across the stimulation. And what she was able to find was that the area under the curve of progesterone levels across the stimulation was even a stronger predictor of success than just the single determination the day of trigger. So here we are not looking to just one determination. We're looking to the full follicular phase, and we saw that the effect is there. Another way of looking at this is look to different populations. Most of the studies that I've shown you are speaking on unselected populations. But is this effect present when we look to different types of populations? Well, studies showing that when you go to high responders, you will see this effect, maybe at a different threshold. Maybe high responders are a little bit more protective and do not show a negative impact until progesterone levels are higher than in general population. And as you can see, significant differences were observed only when progesterone levels were above 2.25 instead of 1.5. So, but still, different population, same effect. Or when you look to poor responders, and here what happens is quite the opposite. Here what it happens is that even at a much lower threshold of defining high progesterone, just 0.8 nanograms per ml, you are going to see already an effect. So also the analysis on different populations, we see that increasing progesterone decreases pregnancy rates. It might just be different thresholds for a different type of patients. And moreover, maybe we should look at where the impact is supposed to be, which is in endometrium. And this is what these two studies that were published exactly at the same time show. The study on the left was performed by our colleagues in Brussels. And they were taking endometrial biopsies the day of pickup and analyzing the gene expression profile at the endometrium at that time and comparing the outcome between patients with low progesterone, intermediate levels, or high levels, above 1.5. And they observed that the gene expression profile of patients with a progesterone of 1.5 was dramatically different compared to patients with low progesterone levels. And again, we did the same in our facilities. In this case, we were taking endometrial biopsies in donors 7 days after trigger, 5 days after pickup, and we observed also that the gene expression profile was very, very different on samples from donors where progesterone was low compared to samples of donors where progesterone was high, and the genes that were affected are directly related with addition. I must highlight that this study was done before ERA, and the analysis of genes was much larger. Finally, criteria of analogy. Are similar agents causing similar results? Or, do we see this type of effect in a different setting? And the answer is yes. When we look to progesterone on frozen embryo transfer or donor embryo transfers with artificial endometrial preparation, we saw that inadequate progesterone levels, in this case low progesterone levels, had also an impact on pregnancy rates. So there is a clear analogy between one hypothesis and the other one, showing that at the end of the day, inadequate levels of progesterone have an impact depending on how they are, if they are high the day of trigger or they are low the day of transfer. So at this point, and as we have just seen, we can say that yes, the relationship between high progesterone and lower pregnancy rates, low ongoing pregnancy rates, can be defined as being cause-effect related. Because as you have just seen, the 9 criteria, the 9 Brathwaite criteria are fulfilled by the evidence that is available out there, and therefore there is no question about this impact. So once we're at this point, why is this happening? Once we know that an increase on progesterone levels will have an impact on pregnancy rates, and once we know that this is a cause-effect relationship, we need to understand why this is happening. And to understand why this is happening, first thing that we need to know and to understand is how follicular steroidogenesis works during the follicular phase. We know that cholesterol is the precursor of the full steroidogenesis, and cholesterol will go into pregnenolone, and pregnenolone, according to the physiologic pathway of follicular steroidogenesis, will convert it into androgens, DHEA, androstenediol, and testosterone at the theca layer cells, and then these androgens will pass to the granulosa layer where they will be aromatized into estrogens. And this is what the classic two cells, two donor trophin concept shows us. And this is called the delta 5 pathway. But we know that there is another route of potential steroidogenesis in the ovary, and is when pregnenolone is converted directly into progesterone and in the granulosa layer cells. And this progesterone cannot be further catabolized into androgens because the enzyme that is needed is virtually absent in the granulosa cells layer. So if pregnenolone is converted into progesterone in the granulosa cells, it will not be converted into androgens. It will stay as a final product. And this is the delta 4 pathway. So keeping this in mind, we wanted to analyze if these pathways of steroidogenesis behave differently depending on how we are stimulating the ovaries. And with that purpose, we defined this prospective and randomized control trial in which we include 110 donors randomized to receive stimulation either with recombinant FSH or with highly purified HMG in the antagonist cycle. All donors were receiving exactly the same dose, 225 units of gonadotrophins per day. All of them were started antagonists on the 6th day of stimulation, and all of them were triggered with a gyrate agonist. And what we did here was to analyze all the hormones that are involved in follicular steroidogenesis across the whole follicular phase from day 1 to the day of trigger. Day 4, day 6, day 8 to the day of trigger. And we also analyzed these hormones in the follicular fluid of the leading follicle. We aspirated individually the largest follicle, and we analyzed also the hormones there. Well, populations were comparable. Randomization did the work, and no differences were observed on the basal characteristics of donors. More interestingly, no differences were observed in ovarian response. The number of eggs, the number of meta-2 phase eggs was the same. Even the number of follicles of more than 10 millimeters or more than 10 millimeters were exactly the same. Moreover, we calculated the total volume of follicles. And why we did that? Because we know that in general, stimulation with recombinant FSH produces more follicles and particularly produces more intermediate sized follicles. So these follicles could have an impact on progesterone production. And what we wanted to analyze here is there was a qualitative difference on the production of progesterone and not just quantitative. And we calculated the volume, the total follicular volume, and we observed that it was also the same. So definitely patients had similar ovarian response, which is what we were looking for. Well, progesterone at the end of stimulation was higher in the recombinant FSH group, significantly higher. But even if we looked to what was the production of progesterone per each ml of follicular volume, we observed that it was higher in the recombinant FSH group, meaning that each milliliter of follicle volume when stimulated is performed with recombinant FSH produces more progesterone than each milliliter of follicle when stimulation with highly purified HMG. And we look to the hormones across stimulation, as just mentioned. And very interesting, FSH and LH were the same. So the ovaries were exposed to the same amount of FSH and LH with both protocols. Very interesting. No more FSH in the recombinant FSH group, no more LH in the HMG group. Pregnenolone, the precursor of the two pathways, was the same. Even 17-OH progesterone was the same. No differences at this point. But look, when we look to the following metabolites of follicular steroidogenesis, progesterone from day 6 onwards was significantly higher in the recombinant FSH group, while androstenedione, which is the delta 5 pathway, was significantly increased in the highly purified HMG group, which is the red line, as you can see there. No differences regarding estrone and estradiol, but when we look to the ratios to analyze how the two pathways behaved, we can see how the pregnenolone to progesterone pathway, the delta 4 pathway, is significantly increased in the recombinant FSH group, while the pregnenolone to androstenedione ratio, the delta 5 pathway, is significantly increased in the highly purified HMG group. And when we look to the exposure across whole stimulation, we can see that in the first half of stimulation, literally till day 6, the exposure to progesterone was the same in the two groups, but from day 6 onwards, in other words, when the follicles become bigger and more hormonally active, the differences become significant, and you have higher progesterone in the rec FSH group, high androstenedione in the highly purified group. Moreover, what was the direct relationship between progesterone and the composition of these two compounds. Very interestingly, we know from studies from Marco Felicori more than 20 years ago that high progesterone was related to high FSH levels. The higher the dose of FSH or the higher the serum FSH levels, the higher progesterone. But interestingly, what we observed was that this is only happening on the recombinant FSH group. When you look to the stimulation, to the levels of progesterone related to levels of FSH, we see that this relationship is only positive in the rec FSH group, but not in the highly purified HMG group. Meaning that maybe the fact of being recombinant FSH or urinary FSH could have an impact here. Moreover, the correlation between LH and progesterone was negative and not different between the two groups, neither the correlation with HMG and progesterone. This is interesting because some studies suggested before that the increase of progesterone at the end of the stimulation was due to an increase on FCG. When you're stimulating with these doses of HMG, you're giving low doses of HCG, and there's no relationship at all with progesterone levels. The only hormone that was related to progesterone levels was FSH, and this only happened in the rec FSH group where there was no counteraction of LH activity. We looked to the follicular fluid, and findings were very interesting too. FSH and LH and estradiol were higher in the HMG group. Obviously, androgens were higher in the HMG group, but progesterone was not. Progesterone was absolutely comparable in the two groups. So regardless that the follicles of FSH were producing more progesterone, this was not reflected at the follicular fluid. Why is this probably happening? Well, we know that progesterone, it leaks the walls of the follicle, and probably what is happening here is that when you give HMG, you are promoting the delta-5 pathway, and therefore you are promoting the conversion of pregnenolone into androgens, while when you're giving rec-FSH, you're promoting the pathway from pregnenolone to progesterone, and this progesterone, which will not be able to be converted into androgens, is not staying in the follicle, it is leaking into circulation, and that's why it is affecting the endometrium, and that's why it's decreasing pregnancy rates. So to summarize, and sorry for a couple of minutes of excess, an increase in progesterone levels at the end of the follicular phase is responsible of a decreased likelihood for achieving a pregnancy in fresh embryo transfer cycles, but not in frozen embryo transfers. The rise in progesterone during the second half of the follicular phase in ovarian stimulation cycle is due to intense stimulation with recombinant FSH that is unbalanced by LH activity. And this is going to alter follicular steroidogenesis, favoring the conversion of pregnenolone into progesterone, which, when it's produced in large amounts, will be released into circulation and will ultimately affect our cycle outcomes. So at the end of the day, if we are going to transfer fresh, it's important that we monitor progesterone levels. If we want to avoid progesterone levels to increase, we should avoid high doses of FSH, recombinant FSH. Otherwise, we will have this issue there. So thank you very much for your attention.
Thank you. Vous avez des questions dans l'assistance? Est-ce qu'il y a des questions? Professor Hamama?
Excellent talk indeed, Ernesto. So how about a low progesterone? So you're meaning about the increase in progesterone beyond 1.5. My question is facing to progesterone less 0.5.
Yeah.
So in this way, we risk to have the same phenomena that high level of progesterone?
A low progesterone is present when you have a low response.
Sure.
Because you have very few follicles producing progesterone, and then you have a lower progesterone. This is not going to affect the endometrium. I mean, a low progesterone at the moment of trigger is not going to affect the endometrium. But what is important here is how the ovaries respond to trigger and how it's going to be the behavior of progesterone after.
But did you advise to cancel and to freeze oil?
No, not so far. We don't have evidence to do that. It's true that when we have a low ovarian response, very low ovarian response, we are trending to accumulate eggs and we are not transferring fresh. And therefore, it's very unusual that we have cases enough to look for a relationship. But definitely, so far, there has not been described with such power or such scientific
So-
rigor and impact of low progesterone. But it's very important what happens in the early luteal phase.
Okay.
I think that is what we should look at and see if the progesterone is very low before trigger, you are not having a good transformation after trigger.
Okay. May I ask the second one question? Very
Yes.
short. So, because as you know, many people now suggest the mixing protocol. For example, you're starting with REC FSH and then you administrating with HMG from the beginning of stimulation or in the middle of stimulation. So maybe you can report now the answer by this way with the mixing we can slow the increasing of progesterone. It is correct?
It might be. I mean, the analysis of progesterone levels in this type of protocol has been only done when you add REC-LH, not with HMG at this point. And
When you're administrating both.
yeah, exactly, from day 6 of stimulation.
Or from the beginning.
Sorry?
From the beginning.
No, if you give LH from the beginning, you're controlling, definitely.
Okay.
Yeah, you get LH from day 1, you're controlling. It's much less clear if when you start on day 6, you're going to see an impact. Indeed, the few studies that have analyzed that, I'm remembering now the study by Wong in Vietnam, she didn't observe any difference on progesterone levels at the end of stimulation when she was adding LH from day 6. And according to physiology, to me, it makes much more sense that you see the effect when you start on day 1, and then the follicular steroidogenesis, let's say, that chooses one pathway and not the other one.
Thank you.
Thank you. That was a very detailed, fantastic endocrinology lecture. I'm wondering two things. Would you suggest we do freeze-alls for all the cycles to just eliminate and simplify the idea that stimulation can have an impact on the timing of the endometrium? And secondly, could the high response to the FSH, particularly if one were to give very high doses of it or very sensitive, you think it could be having an effect on the oocyte as well as on the endometrium?
Yeah, thank you very much. Two very good questions. Question number 1, the evidence does not recommend a freeze-all as a strategy for all patients. This is what the studies done in China and Vietnam, published in New England 2018, show. Moreover, if you monitor for progesterone and you are aware of progesterone, the number of the proportion of cases in which you're going to have this problem is low. It's going to be less than 10% if you are controlling for it. If you don't control, it can go 35, 40% of the cycles. But if you control, it's going to be much lower. Therefore, to freeze all cycles just for this, I don't think is justified. A second point, evidence so far does not show any impact on the egg. We didn't see that in donor eggs. We don't see that in frozen embryo transfers, which you would expect a decrease also in the frozen embryo transfer if this was an impact on the egg. And we don't even see that on PGT cycles. So at least at the levels that we're speaking, which are high progesterone levels, but not ovulatory levels. We're not speaking about levels above 10 or 15. We're just speaking about 2.5. It doesn't seem that there is an impact on the egg.
Thank you very much.
Thank you. Thank you.